My dear students of class 10 of the ICSE board, we are starting today the physics first chapter, that is called the force. In this chapter, today we shall discuss on the theoretical concept. So I want to make your theoretical concept clear today. The first chapter is force, and you know that you have already know about the force in the previous classes. In the previous classes, like the force, when you apply a force on a body, it has different effects. If the body is not rigid, that means the soft, when you are applying a force on a soft body, what you will see, it's get deformed. That means its shape and size may change, and also motion may be there. But if a body is only and only rigid, that means the hard, and when you are applying force on it, there will be only motion, nothing else. For example, this ball is a solid one, rigid body. I am applying force here on it. What you see, it has the motion from this place to this. When I am applying force, it is going to this one. Therefore, this is only motion when I am applying on it, because this one is rigid. Now, the motion. What kind of motion may be there when you are applying a force on a body? There may be two kinds of motion. One, the transitional motion, and another one is the rotational motion. Transitional and rotational. Transitional is also known as the linear motion. Why it is linear? Because it is changing place from one to another. So it is the transitional or the linear. See here. I am applying force on this ball at one point. What you are seeing, when I am applying force, the ball is moving from one place to another. That means it is changing place. This is called the transitional or the linear motion. While in this one, here is the axis. That means what is axis? The fixed point. It is not changing its place. When I am applying force on it, what you are seeing, it is not changing its place. It has remained at the same place, isn't it? It has remained here. It is not moving from this to this. It is not moving its place from here to here. But it is remained at the same place. And applying the force on the beam of this one in the same direction as I had applied the force on the ball. But here it is moving and not the place, but only its blades and the another angles or the particles are changing. That means here it is called the rotational motion. This is the rotational motion. When applying force on it, only rotation is being done. It is not changing its place. So there are two kinds of motion when we apply a force on a body. That one is the first, the linear motion, and second one is the rotational motion. Transitional or the linear motion. You have already read it about it in class 9 and other classes. So here we shall read about the rotational motion. So in the rotational motion, different points terms are there. The first term we are taking here, the moment of a force. Moment of force. This is also known as the torque, and also the turning effect. So moment of force here. What is the moment of force? That means the turning effect. When we apply a force on it, it is turning. It is turning. Turn is taking there here. Here is this turning. So this is the turning effect or the moment of force. Now this moment of force can be measured. Science means measurement must be there. And the quantity, what kind of quantities? Whenever there is the measure, there must become a quantity. What kind of quantities it is? We know that there are two kind of quantities, vector quantity and a scalar quantity. So moment of force is a vector quantity, because when we are changing the force, its direction is changing. When we are changing the direction of the force, its motion, the direction of the motion is also changing. So it is a vector quantity. So I have told you about the turning effect or the moment of the force. Now how can we measure it? So we must have to see what different quantities taking place here. This one is the magnitude of the force. When you are applying a force on it, there must be a force. If I am applying a small force, a small turning is there. If I am applying more force, then more turning is there. Therefore, amount of force is there. And another is the perpendicular distance from the pivoting point. This is the pivoting point. The axis, where the axis is there, this is the pivoting point. And here I am applying the force. So from here, from this point to this point, this distance is called the perpendicular distance. So force turning effect depends upon the amount of force and the distance from the point of applying force to the point of pivot. This is the two factors on which the turning effect depends. How does it depend? Depend upon the product of these two. Product of force and the distance. So you know that the turning effect, that means the moment of force, is the product of two physical quantity. One is the force, another is the distance. Like here, suppose this one is the pivoting point. This is the pivoting point here, and I am applying force here. So the applying force point is here. Therefore, this is the point, and total distance from this one is the distance, perpendicular distance. So if the force be same and the distance be increased, then the product will also be increased. If the force be same, distance be decreased, then the product will be decreased. That means if the distance increases for the same force, the moment of force increases. If the distance decreases, the moment of force decreases. And if the distance remains same, force be applied more, the product will be more, and therefore the moment of force will increase. And if the force be applied less, the moment of force will also be less. Now you tell me, here what I have told you. If suppose this is a door, so where will you apply your force to open it, so that by applying less force you can open it? Will you apply force here or here or here or here? Can you say? Yes. Look here. If the hinge is here, that is the pivoting point, hinge is here, and if we are applying force here, the distance is very less, so we have to apply a greater force, then it will open. But if as we move away from the hinge, then the distance is continually increasing, gradually increasing, therefore the amount of force is decreasing. And if we apply a less force also here, even then the door can easily be opened or the closed. Now you tell, what can you say about the unit of moment? Unit of moment. You know that the moment is the product of two physical quantity, distance and force. Therefore the unit will be made of these two physical quantity. That means if you are taking SI system and absolute force, then Newton and distance is meter. So Newton meter is the unit. But if you are taking the CGS system, in CGS system, then the unit of force is dyne and the distance is centimeter. Therefore dyne centimeter will be the unit. But if you are taking the gravitational force is also there, no? So the gravitational force, therefore the gravitational force is measured as kgf in Newton in SI system and gf in CGS system. So kgf meter and gf meter, and you also know that 1 kgf is equal to 9.8 Newton. So if kgf be changed into Newton meter, then multiply the kgf meter by 9.8, then it will be changed into Newton meter. In the same way, the gf centimeter can be changed into dyne centimeter by multiplying the gf centimeter by 980, because you know that 980 dyne equal to 1 gf. So if you are multiplying gf by 980, it will be changed into dyne centimeter. Moment of force, what I have told you, is a vector quantity. Therefore there is a direction. What direction we apply here? Here we apply two kind of direction, clockwise or anti-clockwise. Clockwise direction or anti-clockwise direction. If it is from top to bottom, bottom to top, then you can easily know which one is the clockwise and anti-clockwise. But if it is horizontally, the motion is horizontally, how can you say which one is the clockwise and which one is anti-clockwise? And if the motion is towards the observer, you are observer and I am experimenting here. If the changing here, the direction of the change is towards you, I am applying force here. See here, I am applying force here. It is where it is moving towards you, either from this side or from this side. But if it is moving towards you, this is anti-clockwise, and anti-clockwise motion is always taken as the positive in physics. And here, if it is moving in that way, that means it is coming inward to me and away from you. This is the clockwise direction, and turn as the negative one, negative direction. So turn. If it is moving away from you and coming towards me, that means inward to me, it is negative and clockwise direction. Now, what are the factors on which the direction of the turning effect can be changed? Direction of the turning effect can be changed in two ways. See here. Here is the force. I am applying the force towards you, towards you. So it is moving in that way, isn't it? When applying force towards you, it is moving in that. It is moving towards you. And the same direction towards you only, but I am applying here. Now it is moving towards me. When I am applying force here, it is moving towards you. When I am applying here, it is moving towards me. So when I adjust, direction of the force is same towards you, but the point of applying is changing. The direction of the motion is also changing. So the first point is that if the point of application of the force be changed, the direction may change. Another one is, suppose the point is same here. I am applying here, it is going to that one. But if the force is applying in that way at the same point, it is, if the direction be changing, the motion is also changing. So if the direction be changed of the force keeping at the same point, then also the direction changes. Or the direction of the force be remaining same, the point be changed, then also the direction of the motion changes. So these two are the factors on which the direction of the motion changes. Now you will think, so what is the advantage of studying about this one? So there are so many common things which we daily use. So these we may take as the example of the moment. For example, when you are closing or opening the door, every time you are, or every day you have to come across with the closing or the opening of the door. That is the moment of force. Or the driver, when he is moving the steering, that is also the turning force. Spanner, what is a spanner? Like this one, see here, spanner. Here, for a knot bolt, you have to tight it. Then you are applying force here, and here this is the pivot. When you are applying here, this and this way, either tightening or loosening it. So there is also the turning of force. This is also the moment of force. In the same way, the pedal, when you are cycling, the pedal is moving when you are applying force by your leg, your feet. That is also the turning force. So many examples may be also taken for this one. Stay tuned with me for the next explanation in the next video.